Doug Konzen is going to give an explanation about how he got involved with pulse motors, which are very similar to Gray, and he's come up with some different perspectives. And he's going to do a demonstration tomorrow, but for right now, he's going to be pointing out the motors. So this is Doug Konzen from Seattle. Doug?
Oh, thank you. Okay, let's see. I didn't get any sleep last night, so if I babble. It's hard to see those lights. I'll start out the history. The way I got started on this, I got in the back of Popular Science, and there's a whole bunch of things you can send for. I sent for everything I could see. I sent away, and for maybe 20 different plans for different things. And the one thing that I thought was pretty neat was this thing called a 300 horsepower fuelless engine, and it's by Creative Science. And so I sent away for this $16 for the plans. And it was high voltage, like 6,000 volts, 200 amps, and it seemed like a really dangerous thing to me. So, and they also sent at the same time I sent for this, they sent me the EV Gray patent. And obviously what this thing was is a poor man's version of an EV Gray motor. And any of you can order these plans. It's in the back of Popular Science's company. They don't always send the plans after you send the money, but you know. So it's true. I didn't, you know. So anyways, so that's how I got. So I got all interested in this EV Gray thing. And that was about 5 years ago. And then I made a couple motors. And first motor, I gave it to this really brilliant drunk guy, and I never got it back. Second motor, I took it to a Bill Beatty science meeting, and it caught on fire. It's made of wood. So I progressed since then. And now I got these things that seem to be running over Unity. The last 3 labs I took it to, they all said it's over Unity and free energy and all that. So, and I like to kind of downplay it. I just say, oh no, you're wrong. Your measurements are wrong. That can't be true. You know, just kind of joking. But that's kind of my attitude right now. But they're kind of fun to build, and I'm just doing this all the time. I spent 16 hours. I got this hotel room here, room 151. It's now a workshop, and I was using my saber saw last night and drill. Steve Ellswick was next door. He liked it, and so that's what this is what I do right now. Is I build these things. And I don't think I'm going to be making any money, really, but I'm trying to sell kits over there, $175, but I doubt anybody's going to buy them, but, you know, whatever. But, so that's kind of my history of the whole thing. And there's some things I've discovered on my own that are pretty interesting. And I'll get into that pretty soon. Okay, first I'll tell you about the operation, how it operates. Okay, it's very similar to EV Gray motor. You have an electromagnetic coil against an electromagnetic coil. And let me grab a motor right here. Are you showing the thing? Oh, I see. Okay, well, let's see. Oh, here's the... So, here's a big motor. Here's
Just talk into it. There's a switch. There's a switch at the bottom.
Light's on. It's not working.
It's working now. Yeah, it's working.
Okay, hello? Testy?
Yeah. Keep talking. We'll get the volume up.
Okay, let's see. I didn't get any sleep last night. I'm serious. Okay. So here's the small motor. Now this is a rotor, the rotor and the stators. Okay, stators, the outside coils, and the rotors. These are north against north, basic EV Gray. Now what makes mine different from EV Gray, besides I only use 12-volt input, is I add these permanent magnets to it. Let's say this thing is spinning. I can't keep my hand still here. Okay, let's say this thing is spinning this way. Oh, okay. Let me grab that. I can't. Okay. So when this thing spins, okay, when the stator's here, let's say it's spinning this way. Can you see that? Now, right after the stator coil, you put a permanent magnet here, right here, and it'll increase the speed of this thing about 4 times, and it'll lower the current draw really drastically. Yeah. And so any of you building like EV Gray motors or anything, just what happens is when the current is cut, everything will reverse polarity. For every function, there's an equal and opposite dysfunction. So this, it's true. So anyways, hey, I talked to this guy, the trucker guy. I talked to him on the phone for a while. It's pretty good. He's right. You know, the trucking industry doesn't control the economy. It's true. They could shut everything down in about 2 days. So that's where you want to go to. You don't want to go to the military or anything, just the truckers. So.
It works.
In fact, I was just in El Paso. I sent. God, sorry. Oh, never mind. I won't go into that. So, what am I saying? Okay, so this permanent magnet is very important. It's very. People don't understand how much it increases the power of these things when you add them to them, and. I think with the new Neubidiums and everything you have, with this high voltage that you have in EV Gray motors, I'm pretty sure you could do this to a Gray motor. You can add permanent magnets right in the rotation. And so the way I found that is I have this friend of mine who's a hippie in 1969. Yeah, he quit school and he went to Haight-Ashbury, and he's a machinist. And he was making, I told this story to some guys yesterday, and he was making rifles for the American Army in the Vietnam War, and he was working for Kalashnikov, and he was making AK-47s, and he was in this little hippie commune. It's kind of a crazy story, but anyways, he said he built this free energy motor there, and he said everybody was dropping acid all the time. He'd walk down the street, hands, and I've never had acid myself. Everybody I know, I don't think it's too cool. They all lock themselves in the room for a few days and stuff. But anyways, so I asked him how this motor worked, and it was a basic Bedini motor. It had revolving magnets and 2 coils on the outside, and it would fire 1 coil at a time. So it would be like 3 inside, pow, this coil, then pow, you know. Just a basic kind of Adams Bedini motor. And what he did is he took clamshells, he said, and he stuck it on the sides of the coils, and then he mapped the flux lines, the way the flux goes around the magnets. And then he took pencil leads, and in the old days they had pencil leads that were really lead. And he made leads the exact thickness of these flux lines. And there were thinner ones on the outside. And then so he stuck these clamshells there, and he tied all these wires together from these pieces of lead and tied it into a diode, ran it back into the battery, and the thing ran by itself. And he was like serious. And he's a really excellent machinist too. And I don't know if it's true or not, but so I went home and checked it out. So I ran one of my motors, and I had some pliers, some iron pliers. And I stuck them in the position where I put my permanent magnets on this thing. And all of a sudden, the thing just took off, just went, wow. I started going way faster. And I go, wow, I discovered something here. And I was going off of this idea that my friend told me. And then I started sticking anything I could, ferrite, steel, And he's seen what could increase it, and I found a permanent magnet in that position would do the best good of anything facing a particular direction. The other way around would slow it down. And so now what I do is, and it's a very precise position where these permanent magnets do, and the way I explain it is it affects the power of the motor when the power is not applied, when the current is turned off. Right when it turns off, that's when you get that big kick oscillation coming back. And when you have a magnet there, it catches it. And it puts it in a different realm of a basic Bedini or Adams design, because it's getting the power when the current is actually off. So it's, and anyways, and so that's I call them the permanent magnet flux bridges. And the positioning of them is real precise. So on my motors, what I do is I mount the magnets right here. They aren't in here right now, but right where these brass things are. And then you can adjust it like this as it's running, like this, so you get the magnet position just right. Oh, sorry. So you can see this, the plates spin. And it's like within a millimeter where you have to hit that sweet spot. And anyway, so that's what makes my thing different than an EV Gray or an Adams, is that I have an EV Gray coils, but then I have these magnets in there. So then I call it a Konehead motor, Konzen pulse motor. Konehead's what I like to go by. That's my internet personality too. So anyways, another thing is the timing for this. It's very important to have adjustable timing on motors. When this thing really gets going, the timing it's at while it's going at a really high speed, it won't even run at all when you try to start it up at a slow speed. So you have to have adjustable timing. The way I do that is I have this plate, and on here is some little reed switches, and they're triggered by a magnet. They just trip it. And when these reed switches trip, it trips a MOSFET. And you have to use really large MOSFETs. This one doesn't get hot at all. It's 40 amp MOSFET. These cost $60. I have to order them. It takes about a week. And there's absolutely nothing gets hot while these run. So you can tell it's very efficient just for that reason. And anyways, another feature I do is I use electric bearings. I call them just electric bearings. And you go to a bicycle store, a skateboard store, and you buy this pack of roller skate bearings or rollerblade bearings. And I bought a lot of bearings, and these things are great. They're real cheap, and they're really well machined. And you get the kind of low-grade ones that are pure steel, pure iron. And then you pop the little protective plates out with a screwdriver, and then you put some conductive grease in there. They use conductive grease like in dryers and stuff because there's a lot of static electricity. And now instead of having to use slip rings, you can just run your current right through the bearings. Now at high voltage, I'm sure these wouldn't work very good, but my motors only draw about 1 amp or so, very low. So there's really not enough current to really do any damage to the steel in there or anything. I have this one motor, it went for about a year. Not continuously, but I've had it running for a year, and the bearings are still good. So it is working. So this is kind of something I've been working on, just electric bearings. And it's a real simple way to build a motor. I'm trying to make my motor design like the simpler, you know, simple as I can get. And also make them easy to change things around and do like that. So when you see my kits, that's kind of the purpose of them. Just make something very simple anybody can use. So anyways, so now you got the timing. Oh yeah, this is something really, really pretty neat. This little magnet right here, it's a little red Alnico magnet. And when you twist this thing, let's say you see that little slot right there. Can everybody see that? Now here's full power. This will have the maximum magnetism against that reed switch, and you'll have the maximum power and the maximum amp draw. Now when you twist this just a little bit, angle it, it'll now cut your amps down and lower your power, but it's a way to adjust the current into your motor real easily. And if you put the slot all the way square like that, it won't trip it at all. So it kind of alters the phase angle against the reed switch. So that makes a real easy way to kind of tune your motor as it's running. Another way is to just actually pull the reed switch away from the magnet a little bit will raise or lower your amperage draw. And what it does is it just makes the pulse longer or slower, 2 milliseconds rather than 1 millisecond. I'm sorry, I keep putting that down there. So anyways, so that's pretty much the timing. Now I also have these roller commutators on that motor over there, and I was working with that. Stefan Hartman on the internet, and was saying that the spark gap, the actual spark gap is what does a lot of things, and you need mechanical commutators, don't use MOSFETs. So I started experimenting with sorts of mechanical commutators, and if you see my motor over there, you actually have copper rollers with electric bearings inside, and so when the brush hits the roller, it spins. And the idea, so what I've always heard, the big problem with the EV Gray motor, I met this guy named Merlin up in Seattle who worked with EV Gray, and he, one of Bill Beattie's science meetings, and he was working on the spark flash problems. And the problem is, like this motor, it's running on 12 volts, but you can get like 1,000 volt kickback, like on my Splatter coils, or when you measure it with some good equipment that can measure high voltage well. And so you can imagine if you're putting 6,000 volts into a motor, the kickback is going to be just tremendous. And that's just the way coils are. They fill, and then when they kick back, it's just a huge raise in voltage, not in amperage, but just voltage. And so they've always had a lot of spark flash problems on these Gray motors, is what I've heard. It's mainly the commutating problem has always been the problem because they can't be that reliable enough. So I came up with this roller commutator idea. The thing spins, so every time the brush hits it, it spins, and it doesn't tear apart the metal really bad, all this flash. Anyways, but they aren't working that well right now. I think I need to use tungsten steel or something. It's kind of something I'm experimenting with, but they can really fly. But still, the best thing you can do right now that I've found is MOSFETs, these big 40 amp MOSFETs. They work great, quiet, and they go really fast. They last forever and they're reliable. And they also have huge spikes they put out. So let's see. Now I'll get into the windings, how I wind the coils. I was wondering, I wanted to ask Norman how the coils in these Gray motors, are they, like you wind a coil, is it just like back and forth, or is it a directional pattern, or is it some special thing? Do you know? It's just...
We haven't torn one of the coils apart yet to see exactly how he wound it, but I'm sure that he does the same way you do. You'd wind a layer, and then they put a layer of insulating tape.
Yeah.
And then overwind layer on top of a layer. It's a very precise pattern that he used.
Oh.
Just looking at the coil, it's about the way you wind yours.
Okay. Okay, well, what I was wondering, one thing I found, this guy told me to use a Teflon tape, you use for plumbing. It works great to put over the layer, like you do a wind on a coil. Put Teflon tape over there. It has a 400-degree melting temperature. It's real thin and works great. But what I was wondering, though, is the way like if you buy a coil like in a store or something, it'll be wound, like the machine will wind it. It'll go all the way through, and then it'll just go back this way all the way through, and just back and forth wind. Now, this guy named Jim Leatherman, who died last year, he's a really great guy. He built like 24 Bedini motors. I used to email him. We used to email all the time. I learned a whole bunch from this guy. But he suggested I try a directional wind, and that's what I do now, and it really works good. This guy, if you go to a site called The Very Last Page of the Internet.com, a guy named Don Adstedt, he lives up by me in Seattle, and he filmed my motor. He has videos of my motors on there. But anyways, he tested some of these directional winds. I'll show you how I do it in just a sec. And he said that it's way, way more powerful. And he showed me a coil that had the same amount of power as one of these small coils I have here. right here. And his was about 3 times larger, way more inefficient. And he said that one matched the power of the directional. So that was, the directional is just way more powerful, at least for what I'm doing, which is colliding coils against each other. And okay, so the way you do that is you take your core. You have to have a core in low voltage. Forget about air coils. At high voltage, you could have cores, made of nylon or something like that. But when you're using low voltage, you got to have a core, like a ferrite or iron. Welding rod steel is maybe the very best thing to use. But anyways, what you do is you wind it one way, then pull the wire straight back after you're done with the winding. And cover that with a little piece of tape or something so it won't chafe when you put the next winding on top of it. So you wind one way, then you pull it straight back, put it over, then wind the same direction again, pull it straight back, wind the same direction again. So it's directional. It makes more of a flux push outward. And that's why I was wondering about the gray motor, if it was directional or not, but you guys will find out when you tear it apart. So, anyways, and then one more thing that you do. This is what I do all the time. I know this isn't that exciting, how to wind coils, but I'm just telling you how I do it. And so, what you do is you also make it cone-shaped, because you can imagine if you're pushing. Let's say you have a coil here, and you're pushing against another coil or something. The windings back here, the magnetism really isn't going to do any good out here. So you might as well make your coils, if it's pushing this way, you might as well make them shaped like this, because this area right here and here really isn't going to do anything. It's wasted space. So you wind up kind of cone-shaped in the end and directional. And it really seems to work well. So here's one of my theories about why all this is happening. I drove all the way here from Seattle in a car and with all my stuff in it, so I had a lot of time to think, and I was thinking about what I'm going to say, And so, anyways, so here's my theory about what's happening. There's 4. I can think of 4 different ways to charge batteries, and one way is a constant charge. That's like your car. You run an alternator, it's 14.5 volts all the time, That's a constant charge of a battery. And then there's a thing I call a zap charge, okay? And that's when you shock it with a high voltage, just to zing it like a Wimhurst generator, maybe 10,000 volts or something. And then you zing it. Don Adstedt demonstrated this to me. You zing a battery, and it will, it's like no amps, just a lot of volts in it. And the battery afterwards, for a few minutes, will just go in voltage, really, just ringing in voltage. And I call that a zap charge. And then there's a pulse charge. I don't know if this is all true or not. It's just my theory I'm doing. Now, pulse charge, I was talking to Bill Alec over there, who's got a great thing going with his motionless shock charger thing. And now pulse charger, if you go to Shucks Auto Parts and you buy a battery charger, it's putting a pulse into that thing. If you look, the diode and a pulse, and with some amps. So that's a pulse charge. And now the 4th type of charge, which is unique to these type of motors, the EV gray, where you have a north against north electromagnetic coils. Now what happens here, I think this is really a key to some theory about this whole thing, is the magnetic field rotates. There's an argument on whether that's true or not, but I'm pretty sure that's true. Around your electromagnet, it's rotating magnetic field. And when you put another one against it, facing against it, it's rotating too, but it's in counter-rotating. So it's a counter-rotating corkscrew smash into each other. Now, when you have electricity, you have three things. You have current flow, you have heat, and you have a magnetic field rotation around your wire. And now, they're all associated, so the thing is, if you can stop your magnetic field rotation, you're going to stop the current flow. and vice versa. You stop, you don't have any current flow, you aren't going to have any magnetic field rotation. So what happens is, Jim Leatherman was telling me this too. He says this is what's happening. He calls it shocking or freezing. You shock or freeze the coils. So what happens is you smash a rotating field against a rotating field, bammo, and at the height of the power, when you get your most power, when your coils saturate, that's when you actually cut your current. Your current stops. So it's like the best of both worlds. You get the most power and your current stops. It's just probably for just a second, you know, I mean, not even, I mean a nanosecond, you know, way down, you know, but it does actually stop it. And so what happens when you stop the current? It kicks back and you get this huge spike, and that goes right back into your battery. So I call that a shock charge. And I don't even know if that's true or not, but that's what I call it, and that's what I think is happening, because we're talking about, he was saying you can't have a closed loop that will be over unity. Norman was saying that, but I was just at this lab in El Paso on Tuesday, and I sent this guy 2 motors. He said he had some big millionaire coming over and all this stuff, and so I sent him a couple motors a few months ago, and so I went down there on my way here, and he brought over all these skeptical science guys, you know. They were pretty skeptical when it started out. And at the end of it, they were just going, oh my God, you know, this is, you know, they were really impressed. And we not only got the battery running the motor, so what I do is I run it on 2 battery system. One battery runs the motor, the other battery accepts all this recoil and everything, and it charges up from the spikes. And the battery being charged really goes up fast. At the last summer, I demonstrated that at Steve Ellswick's exotic research thing down in Phoenix. But also the battery running the motor was going up in voltage. Besides the battery, this is what happened just on Tuesday, and it's like, wow, this is pretty good. And so I left there, and I think the motor's still running. And that was, I don't know, I have to call the guy up. I left him with the motor. So anyways, so I think that's what's happening is it's the shock of the collision of the coils actually has the battery that's running it raise in voltage besides the other battery. And you can also charge more batteries than just one battery. You can do about 4 batteries at one time while you're running off one battery. So what I'm thinking I'm going to do is call this thing a rotating battery charger. You know, that's good enough. And so I'm going to try, you know, here, build your own rotating battery charger that runs on nothing. And
It's got to run on a battery.
what?
It's got to run on a battery.
Yeah, it runs on a battery, but it charges up 4 at the same time, and the battery it's running on goes up in volts. So what more can you ask for?
Play down the details.
So you can put them in, oh, never mind. And so, okay, so what else was I going to talk about? Let's see, Adams gray, fuelless, splatter. Oh yeah, okay, the bifiler windings. Now, that's also called two-conductor, you just call them two-conductor coils, but that's also called bifiler. And it's just when you wind a coil with 2 wires together all the way through. And this is what I've been really working on a lot, because it's pretty fun, because now you have one half of that motor coil that becomes an electromagnet is the motor, you know, it's the motor coil, and the other half is a generator part of the winding. So every time you fire one, you generate in the other half. It's a great thing. So what you do on this motor over here, I have the vertical firing in green and the red and horizontal in red, just to make it simple to understand. And I have a MOSFET firing the red and another MOSFET firing the green. And what I'm doing here, it's a pretty neat thing. It's kind of a self-contained generator motor thing. So what you do is that you take the opposite firing that's not the, you know, you take the vertical firing, you take that induction the kickback and everything, and you throw it into the half of the motor that is just about to fire. And then when that one fires, you kick that into the one that just fired. So you have an alternating motor generator thing. I don't know if I explained that very well. But you, so it's an alternating. It's not alternating current. It's always DC pulse. But I always have somewhere to stick the current, and that's the firing that's coming up on the next firing. So it's a pretty neat thing, and it's all like contained right in there. And you do that with the bifilers, and there's more things about bifilers. I'm not going to get too much into that, but also the two wires together, it's more efficient with the skin effect and all this. But never mind about that. But anyways, okay. So I called this fellow in Alabama named Steve Pitts. He saw my stuff on the internet, and he called me up and he said, you know, you got, this is a few years ago, and he said, you got your motor pulsing, you got those electromagnets pushing and making a lot of power, but you're not doing anything with the backside of the electromagnet. And almost everybody who builds motors I talk to, I always tell them the same thing. You know what you ought to do is you ought to put a bunch of pickup windings on the backside of your electromagnet. Because it doesn't hurt a thing, because, okay, you have an electromagnet here, you give it some juice, blammo, it's pushing. But you have just as much power pulling as you do pushing. And if you don't do something on that back side of your electromagnet, it's all just completely wasted energy. And so I go, hey, you're right, you know, that's a good idea. So what I do now is, at least on my stator coils, my stationary ones, I make the core longer than I really need to have it, and here's the motor coil. This is the coil that draws electricity from the battery, and I call it the motor coil. Now behind it, sharing the core, I wind a whole bunch of windings, and if you put thin windings, you'll get high voltage. Thick windings, you'll get high amps and not as high voltage, whatever you want to have done there. So like on this motor over here, you can see how bulbous those stator coils are, and within those is a smaller motor coil. So that's always something that, you know, works all the time. And so, and what I do is I run all those coils in series on the outside, and I have extra energy that is, you know, normally wasted. And then also, I don't know if you're all following this, but when you have bifiler coils with two conductors, what you can do is use that other half of the bifiler and connect it to the that big bulbous pickup winding. So let's say you have, like I have 40 feet of 22 gauge winds on my motor coil, and I have 300 feet of pickup windings. And so what I do is I take one half of that 40, now these are two 40 feet bifilers. I'm sorry if this is confusing, but I'm just going to keep talking. So the 40, you have two 40 feet motor coils, bifiler, wound together. You only fire one half of those. The other 40 feet is now a generator winding. Now I take the end of that 40 feet and I connect it to that 300 feet of pickup winding. So now I have 340 feet of generator pickup windings that ignite every time the motor coil fires. And those bifiler, the ones right next to the motor coil, those ones really are where the action is. You know, those really get a lot of juice out of them because they're right there, right up front where the motor coil is. So that's what I do, and it takes a while to wind those big coils up. You know, electric drill and everything. So that's called the pickup windings, and I have that all on my website and stuff. And so any of you building motors, I always say, hey, you know, make the core longer and stick some pickup windings back there, and you're going to get a lot of juice. And if you want to, use very, very thin wires, and now you're going to have some really high voltage that you can make actually jump across a spark gap. Now, the spark gap things are really a neat thing. I have this thing called splatter windings here. Okay. So down in El Paso, I had these on the motor that he has right now, and I said that he can keep my motor, but I want my splatter windings back. So, and anyways, the way this works is I got them at a surplus store, and I don't have that many. I only have enough for about 3 motors. They're very, 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 very thin windings, like gauge 60, or something like that. 60, I didn't know. And anyways, I cluster them. This is from that clamshell motor I was telling you about, where I got this idea from. And what happens is when you have these colliding north against north magnetic fields in these motors, it's a halo. It's like, okay, like, you know, John Kennedy got shot in the head, right? And they said that actually he got shot in the head from the front and the back at the same time. And you look at the Zapruder film, there's this big halo around him, right? This in this very city. So, I guess nobody thinks that funny. I don't know. So anyways, well, I'll do it another way. If you have a tomato, okay, it's true. He did get shot at the front and the back at the same time. Okay, but anyways, you take a tomato and you throw it 2 tomatoes against each other. Let's say you have a tomato, and it's exactly 10 ounces. Another tomato, exactly 10 ounces. Exactly the same everything. Throw them at exactly the same speed. They hit in midair. What happens? They smash in midair, and they'll create this splash, halo, radiant halo, right? All around. And it comes out at 90 degrees. That's why I mount these things. They pick up, you mount these on the sides of the motor, and they pick up that energy. And it's amazing. One of these little coils will put out 7 volts, you know. And so I run, right now I'm running 20 of them together. And I was telling Peter the other day about I saw the gray patent, and this same thing works if you ring your coil all the way around like this, like a daisy with pickup windings. You don't have to necessarily push them in there like that. But anyways, so I call this the splatter energy, even though that's not a very good name for it, but it's just what I call it, and so it's too bad. And so, anyways, so I run all these in series. And now I have a really high voltage coming out of this thing. This will zing right up in your arm and out the other arm, and you'll hate it. And so, and meanwhile, it's only running on like 1 amp, you know. It's like 1 amp pulse in a sawtooth on a scope, and you know it's. So, but meanwhile, it will kill you, you know, if you had these taped to you. So, anyways, hold this up. So, anyways, there it is. So this is something unique to my motors. Is I put these splatter coils on there, and you can see they're just clusters there. And mainly I just run the motor and stick coils there, and I find the hot spot where I get the most juice from it, and then I mount them on plates and stick them there. And this is another thing, whoever's making motors out there, or doing anything with motors, the gray motor, bet you if you stuck a bunch of pickup motors all around that thing, you know how much, yeah, you know, you can stop everybody's cell phone, you know, block. So, anyways, so I just discovered something a few weeks ago. My cousin, he's like an Air Force pilot, and he was over, and I was trying to impress him with my motors. I was wanting to show him how much pain they can cause. So what I did was, so I was showing him the spark gap. I was showing him how much of a gap, you know, you can actually make it jump in air, and you can hear it go beep, 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 you know, a little, actually going through the air, the spark. And he's going, hey, well, let's run it into the battery. And so I've already done this before by just taking the energy here and just taking a wire and putting it on the positive, and it doesn't do anything, right? But what's really cool is when you make it go through the air first, then you run it into the battery. And now it creates some sort of, it's pulling in the ether or something, and it'll zap my battery up to like 17, 18, 19 volts. And what I do is I take a little chainsaw spark plug from a small motor or very small spark plug you buy at any store, and you run it through that. And now you can adjust that spark gap. You have to get it very, very precise, very, very precise. And you watch your voltage on your battery while you're doing this. And you can get it so your battery volts just goes up and stays there constantly, way up. And so I ran a motor for 28 hours, and the volts were exactly the same as it started. And I wanted to make sure, and I ran it another 4 hours. It's just exactly the same. The battery won't go flat when you zap it. This is what I call a zap charge. This is the zap charge I was talking about. It's like every time you pulse from the motor, and then before the door closes, you give it a zap of high voltage. And so the battery chemicals, I think what's happening is the battery chemicals are slow. They're slow and stupid, and they can't react in time, you know. And but anyways, that's a really great thing, because besides, like Peter was showing the Bedini circuits with the rectifiers and everything, you know, pulse in, pulse out. Besides that, you can get all this added energy from the splatter windings, and also you can get added energy from the pickup windings. Now, if you did your pickup windings in the same very, very, very thin coils like in these splatter windings, you're going to have so much high voltage coming out of these things, it'll just, you know, you can do almost anything with it. So, and then finally there's the shaft itself, what you get out of the shaft of the motor. And when I do these prony brake tests, what you do is you get a 1-foot bar, you put it on your shaft coming out here, and you cut a hole and slip it across here, and you have a little bolt here, so you can kind of put tension on it. So it's just like grabbing it with your fingers and slowing it down. It took me a long time to figure this out. I finally, Jean-Louis Nadine, he has a great website. He showed how to do a prony brake. So you get a 1-foot bar, you get a gram scale, and you put a little tension on this. Like, let's say it's going 1,000 RPM. You slow it down. You slow it down with a little bit of friction and tension until it goes like 800, steady 800 RPM. And then you see what how many grams are being pushed down. You convert that to pounds, and you can figure out horsepower. When you figure out horsepower, you figure out watts. And so anyways, I'm just talking about the shaft now, the power coming out of the shaft. So at the beginning, I was thinking that this thing has over 100% efficiency just in the shaft alone. So, but when I did a bunch of tests, it was usually about 80% I get out of the shaft. But that's still okay, because you're still getting, you know, the recoil and the pickup windings and the splatter energy out of it too. So it pretty much puts it all over unity without a doubt, is what I'm seeing. And I've taken it to 3 labs the past month. Like, you know, people with, very smart people with labs know everything about electronics, you know, much smarter than me about it. And the past 3 times they all say the same thing. It's over unity and free energy. So that's what I'm kind of doing right now, is I'm getting things confirmed, you know. And so anyways, let's see. Shaft. Let's see, what else can I talk about? Let's see. I can't think of much. I talk about these things all the time. But, oh, questions. Anybody, questions?
Bearings.
Pardon me?
About the bearings.
Bearings? They're roller skate bearings. Oh, you know what I was going to do? How much time do I have?
10 minutes.
10 minutes? I brought a bunch of stuff. George Weissman did this at a show once, and I stole this idea from him. You pass a bunch of stuff around. It's okay. It actually survived, but the splatter winding splattered. It really did. So they're okay though. So anyways. Okay, I'm going to show you, I just want to show you some components here. Yeah, closet rod. Okay, these are the things that you stick on the wall and they stick in there. And you get two of them, put them together, and I cut a little slot and I put a piece of aluminum there and a little piece of copper that spins on the aluminum. So it's a very small roller commutator. I haven't even tried this, but it looks pretty neat. I know it's going to work well. And so here's what I use to wind coils with. Any of you can build these motors. They really aren't that hard. And even if you don't want to buy my kit, you can make something out of wood really easily. And you go to, what's, so, anyways, go to Radio Shack. You buy it for about $3. You buy a 3-pack of magnetic wire. They sell it in every Radio Shack store. And the gold stuff is 22 gauge. And that's what I use. John Bedini wrote me an email, and he was telling me I used to use thick wires. And so this is, because of him, I went to thin wires. And this isn't that thin. This is actually pretty thick. But for what I used to use, this is really thin. But anyway, so this is 40 feet. So when I wind my coils, just to make it simple for anybody who wants to copy what I do, I just use this, the spool right out of here. And it comes out 40 feet, makes it really easy to use. And, oh, here, Radio Shack. This is a full-wave bridge rectifier. This you put across, that's right. And I want everybody to know this stuff, you know. It took me a long time to learn this. So this you put, it has a rectifier is something. It has 4 leads on it, 4 things. The 2 middle ones are AC, and the 2 outside ones are DC. This converts AC to DC. The DC will have a positive and negative. That's what you stick on your battery or your cap or whatever you want to do. The AC, this is the whole trick. When I learned this, people were writing to me telling me you've learned the big secret and everything. What you do, okay, let's say you're using a MOSFET. Whatever you have as your switch, doesn't matter what it is, whatever you have as your switch, you stick those AC legs of this right there, AC, right there, right across the switch. That will draw off all the spikes when those coils collapse, when you cut the current. And and then you run that into a battery. Now you got a battery, you're charging up batteries. All that normally wasted energy is now being taken out, and you can look on a scope and what this is, and it's got the spikes in there. So it took me a long time to learn that, you know, how do you really get, but that's what you do. And use these. It's a 4 amp, 50 volt. Now, the lower voltage you can get, the more efficient if you get 20 volts and you can run your motor and draw everything off it and then you don't blow up your rectifier, you're doing good. You want to get your voltage on as low as you can, and that'll make it the most efficient when you draw off the spikes, the recoil. Yeah, closet rod. Okay, these are the things that you stick on the wall and they stick in there. And you get 2 of them, put them together, and I cut a little slot and I put a piece of aluminum there and a little piece of copper that spins on the aluminum. So it's a very small roller commutator. I haven't even tried this, but it looks pretty neat. I know it's going to work well. And so here's what I use to wind coils with. Any of you can build these motors. They really aren't that hard. And even if you don't want to buy my kit, you can make something out of wood really easily. And you go to, what's, so, anyways, go to Radio Shack. You buy it for about $3. You buy a 3-pack of magnetic wire. They sell it in every Radio Shack store. And the gold stuff is 22 gauge. And that's what I use. John Bedini wrote me an email, and he was telling me I used to use thick wires. And so because of him, I went to thin wires. And this isn't that thin. This is actually pretty thick. But for what I used to use, this is really thin. But anyway, so this is 40 feet. So when I wind my coils, just to make it simple for anybody who wants to copy what I do, I just use this, the spool right out of here. And it comes out 40 feet, makes it really easy to use. And, oh, here, Radio Shack. This is a full-wave bridge rectifier. This you put across, That's right. And I want everybody to know this stuff, you know. It took me a long time to learn this. So this it has a rectifier is something, it has 4 leads on it, 4 things. The 2 middle ones are AC and the 2 outside ones are DC. This converts AC to DC. The DC will have a positive and negative. That's what you stick on your battery or your cap or whatever you want to do. The AC, this is the whole trick. When I learned this, people were writing to me telling me you've learned the big secret and everything. What you do, okay, let's say you're using a MOSFET. Whatever you have as your switch, doesn't matter what it is, whatever you have as your switch, you stick those AC legs of this right there, AC, right there, right across the switch. That will draw off all the spikes when those coils collapse, when you cut the current. And and then you run that into a battery. Now you got a battery, you're charging up batteries. All that normally wasted energy is now being taken out. And you can look on a scope and what this is, and it's got the spikes in there. So it took me a long time to learn that, you know, how do you really get, but that's what you do. And use these. It's a 4 amp, 50 volt. Now, the lower voltage you can get, the more efficient if you get 20 volts and you can run your motor and draw everything off it and you don't blow up your rectifier, you're doing good. You want to get your voltage on as low as you can, and that'll make it the most efficient when you draw off the spikes, the recoil spikes, I guess you'd call them. Yeah?
Have you ever tried Wimhurst static generator on the end of your shaft there for another additional
No.
power source?
No, this guy, he asked if I've ever used a Wimhurst generator on my shaft. But I've been told, a guy named James Bailey, he told me that a Wimhurst is what you really should put on your shaft to keep your caps charged up. If I was running on caps only, for instance. And I do have a Wimhurst generator. I sent away for one, but I've never actually used it. That guy did use a Wimhurst generator, Don Adstedt, and he was showing me, I think I said that already, about how to ring a battery with a Wimhurst. Also, you know what I'd really like to put on this shaft is an Eklund generator. You guys know about what an Eklund is? It's a very efficient no-load generator. It's a very simple thing. I don't know if I'll explain it though. 5? Okay. Well, I'll explain it. Eklund. Okay, I'm going to pass these around so you can look at them. Here's one more thing. Here's a humongous pickup coil that I had in the motor down in and one of my motors, when I left there, I gave me these pickup coils back. By the way, don't go to El Paso if you have any pot in your car, okay? Do you guys know this? You know what they do down there? They have these roadblocks, and they stop every vehicle, and dogs come in your car, and if you have anything, they you know. So don't go that way if you're prone to whatever. So, anyways, so what was I saying? Yeah. So, anyways, what was I saying? El Paso. Okay, coils and okay. So I took this coil from the motor the guy has down there, and so, anyways. This demonstrates what a pickup winding is. All this white part is a generator windings, pickup windings. And only this black part is the motor windings. So this is what I was talking about. I did an experiment when I first discovered this. I was wondering, how far can I go, you know? How far can I make a generator? Maybe it goes back this far for all I know. But it comes about, for what I'm using, 12-volt power. You can only get power for about this much. Any more than that is really wasted. So, okay, you probably won't all this. I'll just put these over here. I won't pass them around because they'll never get around. So, I guess I'll summarize. Tomorrow, what I told Jerry I was going to do is I'm going to do an over unity test. You know, I'm going to demonstrate over unity on my motor over there. And I guess that's what I'm going to do tomorrow. I'm going to run it, and I got all these meters and shunts and everything, and anybody who knows anything about electricity can come up and test it and check it out and stuff. Now, if you want to put this thing in a car or an airplane or a boat or something, you know, it doesn't have much horsepower right now, but what you do, John Bedini had a picture of this on his site too. I call it a spiral. Looks like, let's say you want to build a Ferrari or something, you know, a V12 Ferrari. What you can do is build a spiral 12. And so what you do, like let's say you have a motor like this. Now let's say this unit, this section is working over unity. Now you know, and it's charging your batteries, you aren't using any energy, and it's flying, it's spinning fast. What you do is you just put another one right there. If you want more power, put another one. So if you had something about this long, you could have a nice unit with a lot of power. And what you do is like this one has the coils like this, and the next one, you put it slanted like this a little bit. The next one like this, and then like let's say a 4, the last one would be like this. So now when it fires, the entire, you know, rotation would always have power to it. So I call that a spiral 12. And or if I was to build a car motor or something. And let's see. So I don't know. The only thing I'm kind of worried about is getting killed or something, you know. Because I heard I'm pretty sure this is true. John Bedini did get beat up like 8 years ago, and he had and they beat him up, and he had to go to the hospital for his kidneys. And I get, yeah, okay. Anyways, but never mind about that. Okay, any questions out there? Because I got to wrap it up. No? Okay. So I have motors over there. I told Jerry I was going to bring all these kits, you know. So I brought a bunch of kits. And they were a lot harder to build than I thought. And so I'm charging $175 for a kit, you know, and it's kind of expensive, but I might go down to like $17.50 tomorrow. I don't know. So they're all over there. And okay, any more? I guess that's it.
You did great. This morning has been spectacular. I got to tell you, between Norman and Peter and Konzen, it's blowing me away. And I'm not easily blown, trust me. Come back at 1 o'clock. We got lunch, and you can eat in the local restaurant. There's IHOP. There's a whole bunch of places around here to eat. So come back at 1, and we'll have the next speech, which will be Bill Beatty. Thanks. Thanks. That was great. I'd like to introduce Doug Konzen. We've had some minor problems with the motor, but it seems to be running now, so we're going to jump on it before it blows this hotel up. This is Doug Konzen. First of all, well, go ahead, Doug. You tell them we'll read the measurements.
Okay. Thank you. Thank you very much. Is this on?
Yeah, John. I can hear you.
Okay, here it is. So it's putting out a lot more than I thought it does right now, but I'm kind of an idiot. So anybody come up here and check everything. He says right now, this 6.2 volts times 3 amps is 18.
More than 18 watts.
More than 18 watts is coming out of 1/2 of it. So it's actually all that times 2.
Loaded with a light bulb, right?
And loaded also with a light bulb.
What's the rating on the light bulb?
It's like a 12 volt. I don't know, really.
60 watts.
60 watt.
Well, yeah, but if
And the other side is 14 point something unloaded. This other side.
Oh,
But we don't know amperage.
okay. And so 14 volts coming out the other side? Oh, that's because it's not being loaded. Okay, well, it's running on confusion. Okay? That's it. It's mass confusion. Okay, thanks.
You know what? You got 9-volt batteries running the motor, right?
There is a little 9-volt battery that trips the very low side of the MOSFET, which could be, it draws 0.00001 amp, you know.
Where's the power coming from that's feeding the light?
The way it powers is one battery, right now, okay, what is the, there's a green, look at it as the motor, as there's a green firing is vertical, and there's a red firing is horizontal. And there's a green battery and a red battery. The green battery fires this, the red battery fires this. Now, we've all been talking about EV gray motors and everything. You know all this about coils. They back up when it's coil fills with current, and then when you cut the current collapses, you have this big kickback, okay? Now, the way I collect that kickback is I take a little Schottky diode, which are the fastest diodes you can get, 3 amp, 20 volt. That goes into an AC leg of a bridge, a Radio Shack bridge rectifier at 50 volt, 4 amps. Just a little 50-cent diode and a rectifier. So what I've done is, what happens is it's a DC pulsing, right? It comes in. If you look on a scope, is this scope showing? Is this scope on the output? Yeah, scope shows the output. It's not, I don't know if you really want to call it the output, but what I call it is the rectified recoil. And so all these spikes, you rectify it, you get all those negative spikes out, and you make it all positive energy. So it's all positive energy coming by out of here. And that is what's powering this light bulb and is going through the meters right now. So, that's what I'm doing, yeah.
Are you trying to feed anything back to the battery at this time?
Oh.
Are you feeding any
No,
energy
there's
back?
no feedback to the battery.
Okay. So how much are you putting into the motor to run it right now?
Okay, we need, right now, it's 12-volt battery. And I know we aren't measuring it right now, but it's about 2 amp spikes.
In other words, when the MOSFET opens, you're putting in 2 amps.
When it closes, I mean.
Yeah, I mean when the
switch is complete, you know, every pulse. If you look on a scope, it'll go like this. It'll go like a little sawtooth.
Right.
And then it'll spike back.
Yeah, but that's the comeback.
Yeah.
Okay, no, I'm just talking about what you're putting in, not what's coming back.
It's about, okay, I'd say, okay, the going in is a peak of 2 amps on a scope.
Right, peak 2 amps.
And 12 volts. But
and what's the duration of the 2 amp?
It's about, I'd say this is about a 15% duty cycle.
15% duty cycle.
So it's really, while you would think it's 2 times 12 for 24, it's not. It's 2 times 12, and let's say it's 10%.
Right.
So it's.
None of this means anything unless we get these things on tape. So what? Can we shut down the tape for a second? Hook the light bulb over to this side since it's 14 volts unloaded. Test it. And shut down again. Then we can test how much energy the motor's actually using. How long does it take?
Well,
we have 2 different measurements that would be able to give us all kinds of numbers.
You want to do that simultaneously. We really should be. We got another shunt here. And so we could put this on the battery. We're on the green circuit right now. So if I put this on the, if anybody wants to come up and help, you know, or whatever, you know, because I'm worried about shutting it down, really. So just let it go.
To me, it looks like there's more on the light bulb right now than you're putting into the motor already.
Oh, yeah, just the light bulb itself. Yeah, just the light bulb itself. Okay, so anyways, if any of you are following this is like, it seems to be putting out a lot more than going into it, you know. So, it's pretty good. So, now, I don't know. We don't really need to do much more, do we? You want me to do the other side will be exactly the same as what we're doing now. Because if we do the red one. Okay, let's, we need another light bulb to actually do this. Here's what I like to do, though, is now see what's coming out of the motor right now and is going into this light bulb and the meters. Instead of doing that, what I do is I run that into the opposite battery. This is the whole purpose of this motor with the two separate circuits. You take all this energy and you want to put it somewhere, and you put it into the battery that's not being fired on that stroke. And on the next stroke, like this, you do the opposite. You take that and throw it in here. So you got this flip-flop charge circuit going on. It's a great thing. And I could hook that up if you want. I just hook these up. It'll make it go a lot faster too, and it's already going pretty good. I'm kind of worried about. I could do it. I need a Phillips screwdriver. Okay. Okay. Now this is really fun. Also, if we got some videotapes, a guy named Don Adstead up near Seattle. He called me up. He's built like 24 Bedini motors. He builds all these things. Really great guy. He has an internet page called The Very Last Page of the Internet. Is that right? The Very Last Page of the Internet. .com. Yeah. And if you go there, he's got, I went down to his house and he videotaped 3 of my motors, and he's got this here. Whatever. I don't know why he's saying that. But we did putting it one into the other. Anyways, I'm babbling. Okay, now I got the red. Here's the output. See those sparks? You can see what's coming off of this. See, it's pretty good. Now the whole thing is Bedini or anybody will tell you, you can't simultaneously pulse a battery and try and dump stuff in at the same time. The thing with pulse motors, time is always in your favor. Time is the force that gives you the way to pull energy out of the surrounding environment. That's what I think. Whatever. It's time. And with a pulse motor, between the pulses, you got a whole bunch of time. So that's what you do. You dump. So you can't simultaneously draw. So that's why a lot of people get to a certain stage with some project like this, and they go, oh, I got all this energy, and they put it back into the battery. Oh, and it just goes around. Because it's like a water wheel going around this way, and when you dump water on a water wheel going this way on this side of the wheel, it's going to slow it down, and that's what happens. But you want to dump it over here on the right side of the wheel and make it go faster. And so, anyways, what I can do, basically this isn't going to improve much, but it'll just make it go a lot faster if I dump it in there. And also, I was talking yesterday about the 4 types of charging batteries that I know of. And one is a constant charge, like a car alternator, 14.5 volts constantly, Then there's a pulse charge, where you give it a little amps and some volts. And then there's a zap charge, which is where you ring a battery with a bunch of high voltage, and it just makes it ring. And then there's a shock charge, and that's what this is doing. And that's what EV Gray motors do, is they have colliding magnetic fields, boom, that are rotating. The fields rotate into each other, and the magnetic field rotation stops because it's smashed against each other in a counter rotation. And when the magnetic field stops, so does the current flow, because it's associated. And as soon as you have that current flow stopping, all of a sudden you get a kickback back into the battery, just sort of in a natural way because of this shock of the 2 opposed magnetic fields. And I believe that's what's happening right now, because if I check the batteries don't drain while this motor runs. And you can see it's got power. And just on the shaft alone, if I was to put a prony brake on this with a 1-foot bar on a gram scale and measure horsepower, it'll be about like 80% efficiency at least that comes out of it. So you got all that energy in the first place, plus your battery won't drain down. So it's just like, what else do you want? And then, is there a third battery around here, a car battery or anything? So what now? You can see this system going right now, and now we're running this rectified output powering this light bulb. What you can do is you can run that into a third battery, and you take a 4th battery, like the green one, run it into a battery, the red one, run it into another battery, and you got all that. Now, besides all this, just in case anybody still doubts that you can't have a free energy machine, these globulous coils on the outside here. Now, these are the pickup windings. There's a small little motor coil inside of there that only has a 40 feet, a pretty small coil, maybe like, you know, an inch long, an inch round, of 40 feet. But all surrounding that and all behind of it, sharing the same core, are generator windings. So when you give that a little pulse of current, that motor coil, to make it go, it induces induction in all those other windings. And I actually have 340 feet of windings for 40 feet of what draws. So we were measuring outside there. I could do this right now. Put this on AC. I don't want to drop. Okay. Now let's just take this one right up here. It should say 3 volts AC. I'll put that there. Oh yeah, there you go. And so, I don't know, what does it say? I can really feel this going through my fingers right now. I really can. I was kind of surprised at that.
It's 2 point.
If anybody wants to feel this, and this is not connected to the battery supply at all. This is just induced pickup coil generation right here. Yeah. So what can you say? So you can run all these in series, all 4, and there's about almost 12 volts right there. And the amperage you can just see just by sparks. You can't see them very well. There's just a little bit of sparks. There's not many amps, but there's something there. But this is kind of frosting.
Short those together.
Short them together?
Yeah.
Oh, that's another thing.
See, no drag.
Yeah, exactly. There's no drag. A lot of people, like the Germans, will tell you this won't work because when you start drawing current from these, you're going to bog the system down. But it doesn't happen with this because of this north against north collision. It doesn't matter. It's just still, it just generates coil. It's called linear induction because it's kind of a line. It's the core itself ignites. It's like a magneto, just like a magneto. If you all know how a magneto works. Okay, so besides all this, okay, we have the shaft, we have the output, we have the pickup windings, and then there's this splatter energy, which I really wanted to show you guys, but I can't, but I showed it to you yesterday. Basically, it's all this energy comes out the sides, comes all over the place on this thing. You can take really thin winding coils and just pack them all the way around, all over the place. I like to put them like this, 90 degrees. Now with that, you can get high voltage. You jump a spark, make that high voltage jump a spark gap. You actually take a little spark plug and make it, bzz, 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 you can see it jump through the air. This will draw in energy, what everybody's talking about, where you draw it in from the environment, because the spark gap goes through the air and it kind of like being behind a semi-truck or something, it kind of pulls you into it. So it pulls all these electrons or positrons or whatever you want to call them, come right along with it. And if you take this high voltage and you just stick it on a battery, it does nothing because the battery just dampens everything, just blurp, you know. But when you spark gap it into a battery, now you can get your battery volts to just go way up, 17, 18, 19 volts as the motor's running. Even the battery that's running the motor, because it's such a different form of energy, this high voltage splatter energy, which I don't have hooked up on here right now, it doesn't bog it down either, because it's a whole different thing. So, and that's another one. So you could charge another battery with a splatter energy. So there's right there is, you could have a battery for each pickup coil too, because if you stuck this on you, which will zing you, the generation of the pickup coils, onto just a single car battery over a period of like 4 or 5 hours, it's going to be pretty well, you know, get a good charge. You do it all day, you're going to have it charged all the time. So let's say you had a semi-truck or something, and you had like 50 batteries. You know, you can just run these motors and just keep your batteries charged up. Like you go in, you go sleep at a Hotel 6 overnight, you come up in the morning and all your batteries are charged up. And that's, so this is a rotating battery charger is the product it's going to be, is what I plan on, like I was saying yesterday. So the whole purpose of this was, to run all the back kick. Really the most powerful energy is what we have coming out right now, doing this light bulb, and this is a 60-watt light bulb too, 12 volts. The most powerful energy is what's coming out of this rectified circuit, because I guess it's just a scientific fact that when you pulse coils, you get more back in the induction, in the kickback, but most people will say it's unusable, but you can use it to charge batteries with. Anyways.
It's unusable because they don't want you to use it.
Yeah, they don't want you to, that's right. So, yeah, whoever they are. This guy over here is telling me that the trucking industry are the people who control the whole world's economy. You got to think about that, and he might be absolutely right. Because we all know they're the mafia, right? Except in Canada. There's no mafia in Canada. But never mind, I don't know what I'm talking about. I don't know anything. So, but anyways. Okay, what I want to show is what I made this motor for. Is that I want to run all the recoil kickback that's going into this light bulb. I'm going to disconnect, because you guys seen all the meters, I guess. And I'm going to run that into the opposite battery, and then I'm going to run this one into the other opposite battery, so it's kind of a flip-flop charge circuit going on. But I got to do some, so what I'm doing, there's a red MOSFET and a green MOSFET. The MOSFET's the switching circuit. And that's where you draw the energy out for these things, is from across the switch. You rectify across the switch. You change, because DC current, because it's pulsing, those kickbacks going up, when you look on a scope, it's zinc bonk, and then zinc bonk, and so it becomes an AC type of current, a very spiky AC type of current. When you have AC current, put a rectifier across it, now you have back to DC again, and now you can do work with it. And so what I'm going to do is I'm going to take the rectified DC off of the red circuit and put it into the green circuit. So I keep saying that over and over, but you know, I can't think very well, because now there's the input right there, comes from the, I don't know if I really want to do that though. Maybe we should just bag it at this point, because how much,
Is the light bulb warm or cool?
Come over and stick your tongue on it.
I'll let you do that.
yeah, it's hot. It's pretty hot. I can touch it. What's that? It's not so hot, you know, it burns you, but it's really hot. I'd say it's about 120 maybe, 150 degrees. Your what? Yeah, sure. Is it run on batteries?
No, I need the torque to keep your shaft.
Oh yeah, sure. You can get one of my kits? Build it.
We'll talk about that later.
Yeah. Plus, you know, who's talking about if they had more efficient electrolysis, or George Weissman with his machines, he could, you know, make the electricity with these things to power whatever you're doing. Actually, with anything, you know, anything will work. Okay, so, now I know. Okay, now I got it. I know what I'm doing now. Okay. Whoa. Okay, now what I'm doing is I'm hooking the positive of the, the negative of the red circuit and to the negative of the red circuit to the negative of the green circuit. So essentially, I'm hooking up the output to the other battery. I just did that. Now I'm going to loop this around here, and I'm going to hook up the positive of the red output circuit to the positive of the green circuit over here. I actually got this labeled. And Oh yeah, thanks to everybody helping me out, because it was a total screw-up day. You wouldn't believe it. How they finally, yeah, Edwin, he finally stuck a dime in. We couldn't get it to work, and he finally crammed a dime in here, and it started working by pushing the bearing over, because I had a bad connection to these stupid electric bearings in here. And so he fixed it, and then we came back, we ran it, the dime fell out, it wouldn't work, and it was ridiculous. And so I don't even know how he finally fixed it, because he finally fixed it somehow. He turned the bearing race around or something, but it had a bad connection basically, which, you know, things like this, it just happens all the time. Okay, now here's the way it's supposed to be hooked up, this motor. It's supposed to be kind of a self-contained thing, because you put everything from one thing into the other. Okay, now I've got one battery. Now, actually, the battery, which battery am I charging up now? I'm charging up the green battery. So this should raise up, and should be raising slowly up in volts. I don't know if it will. Anyways, 12.47. I don't know. It doesn't look like it's going to do much right now. But anyways, oh yeah, okay, I'll do the other one. I don't know if that's going to be so impressive, really, but I'm going to do this anyways. I have to disconnect all this. You've seen everything. There it goes. Oh, it stepped up. This last Tuesday, I took some motors down to a lab in El Paso, and this guy called up all these scientist friends of his. They all came over, all these skeptical guys. They're really smart guys, you know. And they did all these tests on my motor, and what they did is they put they measured what's going in, and then they matched what was going in with a resistor, and they had a 150 ohm resistor, and they put that across the output. They're telling me that's the way you should really do this. And they had to have a special really big resistor, because we're using car batteries. And I really don't know what they did, because I wasn't really watching it. But they were like all amazed, because when they did that, the efficiency went up. I mean, it started drawing less. And so, yeah, with the batteries, doing it. So they were all impressed with it. Okay, so now I have the positive and negative of the output of the green circuit. I'm going to take the positive of the green circuit, hook it to the positive of the red circuit input right over here. It seemed to speed up a little bit. Uh-oh, I'm going to lose a wire. Anyways, so I got kits, just in case anybody wants to build these yourself. I got a kits over there, and they're mostly just the frames and a chassis that I built already. And if you want them, you know, you can buy some. And I'm selling for $175. They took a while to build. And then, but you'd have to go back to my room here, and I got all these parts. Like I was saying yesterday, my room I'm staying here is just filled with parts and saws and drills. And so what happened yesterday is a couple guys bought them, and so we went back there and I gave them a whole bunch of parts and showed them stuff. So if you want to build one, you can, you know, and you can contact me on the email, konehead@msn.com, and I'll help you out totally, because I want other people to build these. That's what I really want to do. I don't have any secrets. I don't have any patents. I really don't care, you know. So, and whatever, you know. So, and here goes. Oh yeah, and what I want to do, this is my new thing I want to do, is oh shit.
It's going to go out on PBS, isn't it?
No. Okay, what was I doing? The red to the, okay. Now I'm doing the ground. I'm speaking out loud as I'm trying to think. So this is the output Yeah. Here it is. That is right, what I was doing. Okay. Oh. I don't know if I got that right. Oh, I'm having a hard time. There it is. That went faster, didn't it? You know, just
Circuit to this motor on your website?
no, I don't have the circuit to this one on my website. I haven't even been on the internet for like about a week to check my email, and my internet site, I haven't been there for about a month. Just because I've been trying to get ready for this conference as much as I can, building things. And you know how the internet goes. You can get really involved in it. Okay, so I have the green circuit, the red. Okay, this is right. No, it's slowing it. That's not right. Oh, I'm sorry, you guys. So, red. Green. I'm going to the green to the red. Green to the red. This is it.
What determines the RPM?
Determines the RPM?
What is the RPM and what determines it?
Right now it's about 2,000. I don't know. I'd say it's about 1,500 RPM.
Is it frequency or is it amplitude? You know, like an induction motor is frequency, or you know, a DC motor is amplitude. Is this an AC system or DC pulse?
DC pulse system.
Oh, okay. So it's voltage then. It's voltage.
Well, it's one thing. A lot of things do the RPM. It's how wide your rotor is. If you have it this wide, you know, or if you have it like this, like an ice skater, the voltage going into it. If you put 24 volts into this, these are like bombs. And the resistance of everything. Also, the amplitude, what you're saying, how long the pulse is, will decide your RPM. If you have just a very, very, very short pulse, you don't get much power. If you have a longer pulse, it's boom, you know, more power.
Okay.
The amplitude. So the amplitude makes a difference.
Yeah. It's not like a conventional. Obviously, you can't use a conventional motor to apply in terms of calculating the speed. But if a customer came to you in the future and said, I need 3,600 RPM for an application, could you design it for a specific speed?
You could if you wanted to, yeah. You could make it exactly a certain speed. Because once you can get close and then either put more or less power in, or variable condenser to adjust what?
The electrical input in the motor to adjust the voltage.
I don't know. I don't know about variable condensers, really.
You know, like a light switch on a dimmer switch.
Yeah, but a condenser?
Well, it's a variable condenser. It's
Oh. I don't know. What? A rheostat. Okay. Yeah, you could do that. Make it less or more. Actually, you know what you're all talking about. I know what you're talking about now. It's what the adjustment. I'm going to turn this off. So it survived. That's good enough, you know. Anyways, there's a little magnet up here, right here, and that passes by these reed switches. This is what was causing. We replaced 4 of these this afternoon because we thought it was a reed switch. That's why we were going crazy. But anyways, there's a slot right here. You see that? Now, if you turn this magnet so that the slot is not so straight, but is rather like this, that'll cause more magnetism. It'll change the phase angle against that reed switch. So you can adjust your amplitude and your RPM by moving this little trigger magnet that trips the reed switches that trip in the pulses, and you spin that. And like right now, it's kind of about full power, but I can spin that. If it's like this, straight across, it actually won't even trip the reed switch because the magnetic field isn't strong enough. But you can change it, and from this angle to this angle, you can change the amplitude going into it. And the amplitude on pulse motors is by how long the pulse is. That's the amplitude. You know, when you read it, when you change, you know, longer amps, you'll get more amplitude. So that's how you do that, and that's also how you do the RPM most easily, you know. So And it's really a good adjustment. Another way is to actually pull the reed switch away from the spinning magnet a little bit more, you know, and then you won't have as strong as magnetic field hitting that reed switch. So, and then to do the timing, the actual timing of it is like this. When I was in that lab, I had a much smaller motor with only 2 stators, but it's something I've had for a few years, and it's always been a great motor. And so one guy was watching the amp, the current feed into it as I adjusted the timing, just like a car, you know, you 0 degrees or 5 degrees advanced, whatever, retarded or advanced. And it was within like a ½ millimeter that we locked into the timing position where the current all just went down really nicely, you know, and that's, we hit on the button where it is. So that's how precise the timing is on these things. And you can see this isn't such a precise thing, so it can be improved a lot, that's for sure. Like stainless steel and aluminum rather than plastic and stuff. So, I don't know, I'm kind of done. So, and I'll be over there. So, okay. Thanks. I did it.